Alright, in this video I am going to go over the addition and subtraction formulas that you will find on your trig cheat sheet. Here we have a list of them. There are 6 different ones that we're going to talk about. Sine, cosine, and tangent. And then what you'll notice on the inside is that some of them have a sum of 2 angles, some of them have a difference. And we have that for each sine, cosine, and tangent. So how we're going to use this is we are going to be able to find the exact value of trig functions of angles that are not unit circle angles. So 75 degrees is not one of those nice unit circle angles. However, we can use one of these formulas to help us evaluate this by setting it as to the sum or difference of 2 unit circle angles. So if we think about 75 degrees, we know we're doing cosine here, right? So we've got cosine, and we want to say, okay, well, 75 degrees, right? So 75 degrees, can we write that as a sum or a difference of 2 unit circle angles that we do know? And I think the easy thing here is to think about 30 plus 45, right? So if we rewrite 75 as 30 plus 45, then I can use this formula to evaluate that. So we're going to do, essentially if we let A be 30 and B be 45, then we're going to be doing the cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. So we'll go ahead and write that out. So we're going to think about cosine of 75 as the cosine of 30 plus 45. And then again, our formula said that means we're going to do the cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. And then individually, each one of these we should be able to evaluate, right? So the cosine of 30, that's the square root of 3 over 2, right? That's a unit circle angle. So we know that. We can use our trig cheat sheet to find that if we don't know that. But the cosine of 30, because it's a unit circle angle, we know that's the root 3 over 2. Cosine of 45 is root 2 over 2, so I've got root 3 over 2 times root 2 over 2, minus the sine of 30 is 1/2, and the sine of 45 is root 2 over 2. So now if we multiply root 3 over 2 times root 2 over 2, that's root 6 over 2. I'm sorry, root 6 over 4. We need to make sure we multiply the denominators as well. Root 6 over 4 minus 1 times root 2 over 2 times 2. Root 6 over 4 minus root 2 over 4. So I can combine this, because they're both over 4, I can combine that to a single fraction. Now I can't combine root 6 and root 2. I can't subtract those and make that root 4 or anything like that. So that has to stay as root 6 minus root 2 all over 4. Okay, so that would be the exact value of the cosine of 75. Now, obviously, you would be tempted to just go to the calculator and type in cosine of 75 degrees, and it would give you a value, but what it would give you would be a decimal that you would be rounding to however many places, and that would not be exact. So if we want the exact value, it's root 6 minus root 2 all over 4. We can do the same thing if our angle is in radians, so pi over 12, not something that is on the unit circle, but we want to think about this as, hey, can we write this as the sine of a sum or difference to give us pi over 12? So pi over 12 is actually smaller than anything on the unit circle because the smallest one we have is pi over 6, so think of that as being like half of that. So here's what I would suggest, because sometimes people have trouble with the radian part of this. What I would suggest is I'm going to do a difference, and I want to think of 2 angles that I could subtract, 2 numerators that I could subtract that individually will reduce with 12, because I don't have any unit circle angles that are over 12. Okay, so I need the difference of these numbers on top to be 1, right? Because if I subtract them, I'm supposed to get 1/12. So I need the 2 numerators I'm going to put up here. I need to subtract to give me 1, but they individually need to reduce with 12. And you have some options there. What's jumping out to me is 9 and 8. 9 and 8 individually will reduce with 12. But they also will subtract to 1. Okay. Another thing that we could do is 4 and 3. Or there are a lot of options there. So what I'm going to do is write those in, and then I'm actually going to use 4 and 3 here because that is going to be a little bit nicer numbers for us to deal with. But again, you could use 9 and 8. So I'm going to do 4 and 3. Okay, and then the idea is that will then reduce 4 over 12. That reduces to 1/3. And 3 over 12 reduces to 1/4. So pi over 3 minus pi over 4 is pi over 12. Well, now I can go to my addition subtraction formulas, and I have sine of a difference. So I'm going to use this pattern here, which says sine of the first thing, cosine of the second thing, minus, and then switch those. So we're going to do sine of pi over 3 times the cosine of pi over 4 minus, and then we're going to switch those, so we're going to do the cosine of pi over 3 times the sine of pi over 4. And then again, we can evaluate all these. So the sine of pi over 3 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. And the sine of pi over 4 is root 2 over 2. And what you'll notice is you'll get a lot of the same answers. We're going to actually get the exact same thing that we got up here because I have the same products. So by the time I multiply these and then subtract, I'm again going to end up with root 6 minus root 2 over 4. Okay, so let's look at maybe using this in a different way to maybe simplify something. So if I have sine of 20 times the cosine of 40 plus the cosine of 20 times the sine of 40, and I want to find the exact value of that, 20 and 40 aren't unit circle angles, but what I notice is that it fits one of these patterns, and it's the first one here. So if you look at this first one, it's sine A cosine B plus cosine A sine B. And so this will simplify to the sine of A plus B. So I'm going to use this formula going backwards. This is just going to be the same as the sine of 20 plus 40, which is the sine of 60, which is the square root of 3 over 2. Okay, so using it backwards is much easier. I just have to find which one of those patterns it fits and apply that. Okay. Now we'll use this addition and subtraction formula idea to prove an identity. So I'm going to start with the left-hand side here. There's more to do on that side. I've got the cosine of pi over 2 minus u, and I want to prove that that equals the sine of u. So I'm going to do cosine of a difference. So that's cosine cosine plus sine sine. Okay, that's this one right here on the bottom. So cosine cosine minus or plus sine sine. So that means I'm going to do the cosine of pi over 2 times the cosine of u plus the sine of pi over 2 times the sine of u. Well, that will equal the cosine of pi over 2 is 0. So if that's 0, I've got 0 times the cosine of u plus the sine of pi over 2 is 1 times the sine of u. And 0 times cosine u is just 0, so then I just end up with sine u, which is the right-hand side, and there's our proof. Okay, so that's addition and subtraction formula. It's pretty easy. Just figure out which one you're using, and then follow the pattern and apply those values.